Today, we are diving into a massive question for pretty much any researcher out there. How can we actually use AI to analyze huge amounts of text without, throwing scientific rigor out the window? We're going to break down a new open source framework that says it can do exactly that.
So here's our game plan. We'll kick things off with what I'm calling the AI researcher's dilemma. Then we'll introduce the framework that's built to solve it. We'll see how it works, dig into its most critical feature, the sensitivity check, and watch it in action with a real-world case study before we look ahead to what this means for the future of research.
All right, so social scientists are practically swimming in more text data than they know what to do with. Social media, company reports, you name it. Trying to analyze all of that by hand, it's basically impossible. So large language models, LLMs, they look like this amazing shortcut, right? But they also bring a pretty serious challenge to the table.
And that gets us right to the heart of it. Can we really trust AI for serious research? I mean, sure, LLMs are incredibly fast. They can chew through text at a scale we've never seen before. But for academic work, speed isn't everything. We've got to know if the results are consistent, if they're reliable, if they're scientifically valid. Can you really trust a black box to produce research you can defend?
This slide really nails the problem. On one hand, you've got manual work by human researchers. It's slow, it's expensive, but you know what you're getting, it's consistent. On the other hand, you have LLMs. They are lightning fast and can scale to massive data sets, but their results can be variable. Ask a slightly different question, and you might get a slightly different answer. That one word, variable, that's the whole problem we need to solve.
So how do you deal with that variability? How do you tame it? Well, that's exactly where the LLM annotation framework comes into play. It's a whole methodology, a set of open-source tools designed from the ground up to make AI-powered text analysis truly trustworthy enough for peer-reviewed research.
And let's be clear, this isn't just another piece of code. It's a whole system. It gives researchers a structured path to use LLMs for classifying text, but the real secret sauce, the magic ingredient, is the built-in process for doing a robust sensitivity analysis, and that's what makes sure your findings are actually solid.
Okay, so the framework lays everything out in these 4 clear steps. First, you have the LLM annotate your text. Simple enough. Second, you check how well it did against a small sample that a human already coded. Third, you take those AI-generated labels and plug them into your statistical models. And fourth, and this is the most important part, you systematically test how your big conclusions change when you tweak the instructions you give the AI.
So how does a researcher actually get their hands dirty with this? Well, one of the coolest parts is just how accessible it is. It's available for both Python and R, which are the 2 heavy hitters in social science. So it's designed to plug right into the workflows that researchers are already using.
And you really don't have to be some kind of coding genius to get going. The heart of the framework is this one simple function where you just plug in the key pieces. You tell it where your data is, pick the model you want to use, like GPT-4o or Claude Haiku, give it your prompt, and tell it what kind of statistical analysis to run. The framework does all the heavy lifting in the background.
Okay, now we're getting to the feature that really makes this thing special. This is what elevates it from just a handy script to a real scientific instrument. It's the sensitivity check, and it's built on a really simple but powerful idea. A single prompt is never enough to be confident in your results.
Think about it like this. If a doctor gave you a really serious diagnosis, you'd probably want a second opinion, right? Maybe even a third? Well, sensitivity analysis is basically the research version of that. Instead of just trusting one prompt, you systematically test dozens of different ways of asking the AI the same fundamental question just to see if your conclusion still stands. It's all about checking for robustness.
And the framework makes this super easy because it helps you create all these different prompts using well-known strategies. You can try a direct zero-shot command, or you can give it a few examples with few-shot. You can ask it to explain its reasoning with chain of thought, or even tell it to act like an expert in the field. The goal is to try them all and see how consistent the results are.
And this chart shows you exactly why that is so important. Imagine these are the results from your model using labels from 3 different prompts. See how the final number, your main finding, is a little bit different for each one? If you didn't do a sensitivity analysis, you'd only see one of these bars. You just pick one, and you might think that's the final answer. This framework lets you see the whole picture, the whole range of possible outcomes. Now, you might be thinking, okay, running 50 different prompts on my data set of 1 million documents sounds expensive. And you'd be right. That would be incredibly slow and costly. So the framework has this really clever feature called bootstrapping.
For each different prompt, it just analyzes a random sample of your data. This cuts down on costs and time like you wouldn't believe, but it's still statistically robust enough to check your results.
All right, this all sounds great in theory, but let's see how it actually performs out in the wild. The people who built the framework used it to analyze a ton of data from crowdfunding websites to answer a pretty interesting research question.
So the question was this: if a project's description talks about having some kind of social benefit, does that make people more likely to give it money? To figure that out, they had to go through thousands of project descriptions and classify them. Does it have a social benefit or not? A perfect job for an LLM.
So what they find? Well, instead of just running one prompt and getting one single number, they did the full sensitivity analysis with 50, that's 50, different versions of the prompt. And after all that, they didn't just get one fragile answer. They got a whole distribution of results, and the average effect was this, 0.15. This number is the one you can trust, because it's not a single data point, it's a robust average, and that makes all the difference.
And that really is the bottom line. The framework doesn't just spit out an answer. It gives you a confidence interval around that answer. It shows you a range of results, so you can report your findings and be totally transparent about how sensitive they are to the way you prompted the AI. And that leads to conclusions that are so much more reliable, so much more defensible. So what does a tool like this actually mean for the future of social science, or really any field that works with text? Well, it's a pretty big deal. It signals a major shift in how we should be thinking about using AI in our work. So let's just recap the big takeaways here. 1. LLMs are amazing, but they're variable. 2. This framework doesn't fight that variability, it gives you a structured way to manage it. 3. Sensitivity analysis. That's the absolute key to doing rigorous academic work with AI. And 4. All of this together transforms the LLM from what felt like a risky shortcut into a genuinely trustworthy tool in the research toolkit.
Which leaves us with one final, pretty exciting thought to chew on. For decades, the kinds of questions we could even ask were limited by the sheer amount of text we'd have to read. Now that we have a way to use AI with real scientific rigor, what new worlds is that going to open up? What new discoveries are just sitting there, waiting for us in all that data?